Mydreamsacademy.
Good day friends, welcome to another episode of my Dreams Academy online tutorials. I'm your tutor Emmanuel Prime, and today I'm going to be taking us on some physics questions from the post-UTME past questions. Okay, so the question we're going to be looking at today is from UNN 2009-2010 post-UTME. The question says, a body falls freely under gravity from a height of 10 meters on top of a platform 0.8 meters above the ground. Its velocity on reaching the platform is, okay, so basically we are looking for the velocity of an object that is falling from a particular height. Okay, so let's use this ball to represent the object. Okay, and then this is our ground level. This is our ground level. Now the height from which that object is falling to the ground is 10 meters. Okay, so from here down to the ground level is 10 meters. But according to the question, the object did not fall to the ground. The object fell to a platform. Look at the platform. So this is my platform, and then the height of this platform, according to the question, was given as 0.8 meters. So the question is asking us to obtain the velocity of the object on reaching the platform. So look at the object now. Okay, so when it reaches the platform, we are asked to find its velocity. Now, for us to be able to answer this question, we need to understand the energy conversions occurring in the question. Okay, now when the object was initially at this point, of course it is at rest momentarily, and at that point it possesses potential energy. Okay, so at this point it has potential energy, and we know that the formula for calculating potential energy is mgh, where m is the mass, g is your acceleration due to gravity, and h represents your height that is falling from. Okay, and then secondly, when the object starts falling, that potential energy is converted into kinetic energy, and we know kinetic energy is half mv squared, where m is also the mass and v is the velocity it is falling with. Okay, now to be able to obtain the velocity on reaching the platform, we need to understand that there is an energy conversion. Remember, at this point there is potential energy, and when it is falling it has kinetic energy. And according to the law of conservation of energy, energy is neither created nor destroyed, but can be converted from one form to another. Okay, so we can simply say that potential energy is equal to kinetic energy, meaning that potential energy mgh is equal to kinetic energy half mv squared. Okay, so we can simply say let m cancel m on both sides, and we are left with gh equals 1 over 2v squared, and then we cross multiply. Okay, cross multiply, 2gh is equal to v squared, or we say v is the square root of 2gh. Okay, now but the problem now lies, which height are we going to make use of here? Because we have two heights. We have 10 meters and we have 0.8 meters. So which one are we going to make use of? Now, but the answer is simply the object did not fall down to the ground. Assuming it fell to the ground, we would have used 10. Okay, so the object is falling from that height to the platform. So the height we are going to make use of is the difference between this and this, because the object is really falling from here to here. So that is our height now. Okay, so h is equal to 10 minus 0.8, and that will give us 9.2 meters. Okay, so the height we are going to make use of is 9.2 meters, and then we have v is equal to the square root of 2 times 10 times 9.2, and v becomes equal to the square root of 184, and then when we get the square root of 184, v would be equal to 13.56 meters per second approximately. Okay, now going back to the question, looking at the options, what do we have? Okay, so in the options we have 7848 meters per second, 80 meters per second, 78 meters per second, 27.7 meters per second. Okay, looking at that, we don't have the answer in the options. Okay, which simply means that there is probably an omission. But what matters is understand the concept behind the answer to the question, and that is how you can get the right thing in life. Okay, so thank you very much for staying tuned to this. I hope to see you next time. Thank you very much.